This conference will now be recorded.
Yeah, so yesterday we discussed about, actually we should know that how the things are related. First thing is that since data is increasing so much, so the single node systems or the centralized systems, basically the SMP systems are called single node systems, right? So symmetric multiprocessing. So that means in single node systems, what happening? All the data is present in on the same node or same computer. But as the data increases, you have to load hundreds of millions of records in single system, means obviously it will take more time. It's like having single door to accommodate 500 movie viewers, movie hall. If we have single door, what happens? Everyone has to enter only through that door. Definitely it's not a good idea, because it will take minimum at least some half an hour. They cannot wait movie to start till half an hour. So same thing. So users is not happy if it's going to take more time. Okay, although the data is increasing, yes, data will increase. Okay, data increasing means what? Business is increasing for the customers. So they have come up with a plan like, okay, so we have to somehow improve the both loading and retrieval of the data. Loading means while inserting into data warehouse. Retrieval means while doing select query. Generally, the BI reporting, analytical reports we call BI reports, is to retrieve the data what is there in the data warehouse. So that is called retrieving. So both loading and retrieving should be done faster. So that means same thing like going into cinema hall, movie hall, and coming out of movie hall. For example, movie completed at 3 p.m. But if it's take half an hour for all the movie watchers to come out, then when will they start the next? Okay, next movie. So definitely it's not a good idea. So what they did is, okay, so they have come up with plan. In fact, that's where the distributed systems came into picture. So let us store the data across multiple. So okay, so multiple nodes they have, and okay, let us distribute. Okay, then if the data is there in multiple nodes, okay, then we have to find a mechanism to distribute the data. So that's where the distribution mechanisms came. So all the modern data warehouses will be like this only. Data is not stored in single node, it is stored in multiple nodes, and they are distributing the data across all the nodes. Okay, cool. So, but maybe terminology is different. Okay, Teradata they call it as primary index, Redshift they call distribution key, and Azure they may call something else. Google BigQuery they may call something else. No flip, but finally it is the one of the column in the table which is used to distribute the data across all the nodes. Bus. Okay, cool. Okay, then since we are learning about Redshift, so what is this distribution keys, or how they are distributing? So they are distributing using different techniques, or they call it as style. Okay, distribution style. Okay, what are the different distribution styles? Or in I can ask in any way, what are different types of distribution styles or distribution mechanisms? You can say anything. Okay, there are different ways of distribution or distribution styles in Redshift or key, all, even auto. Key means you will be defining one particular column as the distribution key. We call dist key. Okay, based on which it will distribute the data to all the nodes. I'm saying nodes, but actually data will be distributed to the slices within the node. You should know that. Okay, cool. Then here we need to note one point is that if records are unique, yes, it will be distributed evenly, uniquely. If there is duplicate records are coming, they all will be going to same slice. Okay, I can say one thing. For example, you are going to, movie theater, right? So people with same ticket fare, they are going into same, right, same class. For example, all 10 rupee ticket people will go only 10 rupee. Okay. And if that is 20 rupee person will go into different. 30 rupees person will go into different. But if another 30% comes, then he will go into the same queue where other 30%. So like that, of course, there is only a few classes like 10, 20, 30, or 50, 100, 200 plus. But okay, here, I mean, I just gave as an example. So, yeah, unique values will be evenly distributed. If there is a repetition of the value or duplicates, they will be going into the, I mean, they all will be put into the same slice where, and for example, all tens, okay, all tens will go to one slice. Okay, let's say tens are repeated some thousand values, then all tens will go in. Then next value 20 came, let's say. Then 20 repeated 2000 times. Then all 20s will go to a different slice. But they all will go to that slice only, like that. So duplicate values will go to, I mean, same slice. Okay, then we also seen that if data is not evenly distributed, then the purpose of distribution systems itself is lost. How? Yesterday I said, I mean, day before yesterday. If you have 100 million records, out of which 75 million records are going into same slice, then what is the use? It's taking 75 million seconds. But if 100 million records are distributed into 25 million, 25 million, 25 million, 20, like equally to 4 slices, then it's taking only 25 million seconds. So the more evenly data is distributed, that much benefit we will get with respect to performance. So the utmost attention should be going to data distribution. Okay, so now we know that, yeah, we have to take I mean, the most attention. Okay, then how to distribute, that's where the key is key. So there are different styles, key or even auto. So key means it will evenly distribute, but we came to know that if duplicate values are there, then it will not distribute. So we have, our attention should go the values of the key column we are defining. So we have to make sure that it is unique. Okay, then okay, all unique values will go to, yeah, different slices, so data will be evenly distributed. Or somebody may think that, yeah, we'll define is, even, because even will anyway equally distribute. I mean, at this point of time, it seems like yes, we should define a key which is most unique, or we should define it as even, because it evenly distributes. So it seems like that is right. So but we should go further. What is the further? So what is the purpose actually of loading? The purpose of loading or keeping in data warehouse is to retrieve the data, right? Yes. And when retrieving, you're not just retrieving one table. The report will include joins with multiple tables, customers, orders, okay? So location, region, because reporting will happen on multiple dimensions. Okay, we want to analyze city-wise sales, location-wise employees, or location-wise sales, or date-wise, week-wise, month-wise. So we will be analyzing the data with respect to different dimensions. So that means we need to join the data with different tables. So then finally your joins are, yeah, joins only. Your joins should be optimized. It's not that you just load the data evenly, but your select queries should be running faster after you load the data. So, and our select queries are not always just select sort from single table. They involve multiple joins with multiple tables. So those should be run well. Okay, cool. So now how the data should be distributed to in such a way that joins should be helped. You see, if joins are not helping, that means these distribution styles are not helping to efficient joins, it's of no use. So, or in fact, we should decide or design the distribution styles in such a way that it should help the joins. Okay, fine. Then I'll just briefly say key means, yes, you will define a column, and all means, oh yeah, all means what happens in all? All means entire copy of the data will be put in the first slice of each node. Okay, fine. Even means it will just round robin, means equally distributes the data 1 2 3 4 1 2 3 4 5 6 7 8 9 10 11 12 like that. If you have 4 slices, or if you have 10 slices, 1 2 3 4 5 6 7 8 9 10, again 11 12 13 14 15 16 17 18 19 20, like that, round robin. So auto means, yeah, generally first, yesterday, yeah, you have asked which is most used. Actually, key is used. Okay. Then, if it is small tables, all is used. Let's say you don't know what is the column and how unique it is, and you don't know even how big the table will be. Okay, fine. So at that time, you can also define auto. Okay, auto will actually starts if, for example, new table is deployed into production. Actually, at the time, you may not have any idea how big the table will be. So yes, initially you can, I mean, you can just leave it. It will automatically consider it as auto. Auto will initially starts with all distribution style, and then if the table is too big, it will convert to even. Okay, fine. But still, it's always better that control will be in your hand, meaning you define the key, because after once you deploy the table, you know, right, which on which column it is joined with other tables. So based on that, you should be able to define the key. So yeah, that will help you. Okay, because I said even will not help the joins. Okay, now we will see how these distribution styles is are linked with the joins. Okay, cool. See here the goals. Distribute data evenly for parallel processing. Okay. Yeah, that means everything should be done parallelly. Like I said, if the data is not processed parallelly, the purpose of distribution itself is lost. Okay, that is the number one goal. Number two, minimize the data movement during query processing. Yeah, this is very, very important. Minimize the data movement during query processing. Okay, so what does it mean? Minimize the data processing during query. Minimize the data movement during query processing. This is very, very important. I will tell you. So okay, so yeah, actually this diagram shows two tables. Okay, with key is the table T1 means table one with key distribution style. T2 also key distribution style. Okay, so yeah, okay. I will tell you the most easy way. Okay, how to understand. Okay, so for example, you have employee table. Okay, employee table has let's say 10 million records, or let's say you take any table. Let's say employee table has 100 million records. You take 100 million records. Okay, but any company will have how many departments? For example, a company will have how many departments? Maybe 5, 10, 15, 20, or 50. I mean, 50 is too much. You see, how many departments will have? For example, you take any finance or bank, maybe deposits, loans, I mean, credit cards, or what not. Maybe two-wheeler loans, three. I mean, again, that will come under loans. Okay, subcategory, and home loans or insurance. So altogether, they may not be even 10 or 15. Okay, so let us take we have 50 departments. 50 is again a huge number, but let's say it's a multi MNC and it has very, I mean, multi business. Okay, with so multiple departments we have. Let's say departments 50. But all these 100 million people are belong to one of the department. Do you agree or not?
Yes.
Okay.
Yes, sir.
I want response from both of you when I ask the question. Okay, this is very, very critical, and this is the key point in performance troubleshooting. And yeah, this is very, very crucial point. Even most of the IT people also don't know. Only a few people knows. Okay, so yeah,
Okay.
that's it. Paying attention. So okay, now okay, so 100 million, let's say, don't consider 100 million, you take 10,000 employees. Okay, for simplicity purpose I'm telling 10,000 employees you have 50 departments. Okay, 50 departments, 10,000 employees. Okay, so what is our distribution strategy? Okay, so okay, everyone, so definitely employee table will have employee ID is the key. Okay, so employee, that means it will be distributed based on employee ID. And the department table will have department number or department ID. Okay, you take department number as the ID and it will be distributed based on department number. Okay, so employee table is distributed based on employee ID and a department number is distributed based on department number. How many departments you have? You have 50 departments. How many employees you have? You have, yeah, you have, let's say 50,000 employees. No, yeah, 10,000. Okay. Yeah, okay, 10,000 or let's say 50,000 employees. Okay, 50,000 employees. Okay, so 50,000 employees, 50 departments. Okay, so they all distributed. Okay, evenly. I mean, evenly means yeah, based on their, unique value for department number, department ID, for employee table, employee ID. So cool, because employee ID will be unique, so that will be distributed evenly, and department number also unique, so it will be distributed evenly. So let's say they went, okay, they went for some anniversary celebration, or they went some outing. Okay, so they went some outing and they went for a some 5-star hotel. They booked 50 rooms. Okay, 50 rooms. 50 rooms. Okay, and okay, employee table should be distributed across 50 rooms. So okay, each room.
Writing something?
No, I'm not writing anything.
Oh.
Just listen. Okay, so 50 rooms they booked it, and each room, how many employees will come? Let's say I have 50,000 employees. Each room, how many employees will fit in?
1,000.
Yeah, 1,000 employees. Okay, so they are distributing the employees based on employee ID. So 50 rooms, so employee ID 1001, 1002, like that. So first they distributed 50, then next 50, next 50, next 50. So each room they will have 50,000. On each room they will have 1,000 employees. So 50 rooms, 50,000 employees finished. That point you understood?
Yes, sir.
Yes.
Okay. Next, similarly for department, departments table also distributed, like that. So 50 departments, 50 people actually. Okay, departments also you consider as a person. Okay, now okay, representing the department. Okay, so first room have department number 1, second room will have department number 2. Okay, so third room will have department number 3. So like that. So 50 departments, 50, one department in each room. You understand?
Yes, sir.
Somnath, you understood departments, how they distributed?
Yeah, 50 departments in each room, you said. Previously 1,000 employees in each room, and here we have 50 departments in each room.
Not 50.
Yeah.
50 departments you have to distribute across 50 rooms.
Yeah, so 10. Yeah, so one department.
Yeah. So each room, how many departments you have?
One department.
One department.
Yeah. Yeah. So in each room you have only one department. Okay. Okay. Cool. Okay. Now you see. You have 50,000 employees, 50 departments. So 50,000 employees are distributed to each room. So they 1,000, 1,000, 1,000, 1,000. in each room, and then departments they have distributed. Okay, only 50 departments are there. Okay, 50 rooms are there. So each room you got one department. One. Okay, first room one department, something like one. Second room, second department, something like 2 or 10, 20, 30, 40, 50, 60, 70, 80, 90, 20. Okay, so something like that. Okay, but one department only in a room. Obviously, right? 50 departments, you can only distribute to 50 rooms. Each room will get only one department. That you agreed till now?
Yes.
Yes.
Okay, now. Okay, now the question. I want to know all the employees who works for a HR department. Okay, that is the question. I want to know all the employees who are working for HR department. Now you tell me, HR is only one department in the among all the 50 departments. So HR might be there in some room. Yes or no? HR department is there in some room
Yes, sir.
among those 50 rooms. Clear?
Yes, sir.
Yes.
Okay. So HR is there. For example, HR is there in some room number 30. Okay, room number 30, HR is there. And room number 30, how many employees are there?
1,000.
1,000. Yeah. So what is my question? I want to know all the employees who are working for HR department. Then immediately room number 30 people will check. Oh, I am HR, I am HR, I am HR. He will say from room number 30. Yes or no?
Yes, sir.
Yes.
Yeah. So let's say out of 1,000 people that are present in room number 30, let's say there are 100 HRs are on. I mean HRs are very less in number, but let's say there are 100 HRs are there in that room. Okay. So 100 HRs are out of 1,000 people. 100 HRs came because they are in the same room. So as soon as someone came, okay, I want to know who are the HRs in this room, because HR department went into that room. So everyone will say who are the HRs. They will raise the hand or they will say that yeah, I am the HR, I am the HR. So totally we got some 100 HRs from that group. Are you clear till now?
Yes, sir.
Yeah.
Okay, now HR department is there in which room?
30th
Room
room.
number 30. Yeah. So now, so room number 30, we got some 100 people, okay, who are working for HR department. So does it mean that there are no HRs in other rooms?
No.
No, sir.
I want answer again.
No, sir.
Somnath, does it mean that there is no HRs in other rooms?
No. No.
Okay, so if we want to know who, I mean, because we have to consider HRs from all 50 rooms. Okay, but right now only HR is present only in one of the room. Okay, so we got, okay, because they are present in the same room, so immediately we got this room HR count. But what about the HRs available in other rooms? So in order to know the HRs available in other rooms, they should also, I mean, other rooms also HRs are there. Okay, so how do they communicate, or how do we bring that HRs into our list or count? So either for example, this HR department, okay, this representing person should go there and count, or at least yeah, get who are the HRs available. Like that, he may go to every room and ask. I mean, somebody should go, right? Otherwise, how do we know? So one of this person representing as the HR, he should be going to every room and asking, I want to know who are the HRs, to get the total count of the HRs in all 50 rooms. Yes or no?
Yes.
Yes, sir.
Yeah. So, or yeah, that is one method. Okay, that is one method. Or second method. bring all the employees and department outside of the rooms. Maybe something like, or during fire exercise we have some assembly hall, right? So bring all of them into some ground and put all the 50 departments on side or this, and check who are the HR. Then it's easy because only two on side employees, on side department. So who is HR means everyone will say, okay, I am HR. Then he will get the complete HR count. You understood this point? Second point?
Yes, sir.
Yes.
Yeah. So, okay. But how much difficult it is to bring all the 10,000 employees or 50,000 employees into a ground and then bring all the 50 departments into ground. Definitely that is something, it seems like rowdy and a lot of rush and this and all. Yes or no? Moving 50,000 people into one place.
Yes, yes, sir.
Yeah. So, but in the first case, already 50,000 people are distributed to 50 rooms and each room has 1,000 people. Okay. So it seems like don't disturb those 50,000 people. It's better that the one HR department is there in room number 30. You go to each room and check who are the HRs. Is it not easy?
No, no, sir.
No,
Yes.
I'm asking what no, what is, what you understand? Professor, can you tell me what did I ask?
Yes, sir. ప్రతి రూమ్కి వెళ్ళి చెక్ చేయడం అనేది కొంచెం కష్టంగా ఉంటుంది. అంటే హెచ్ఆర్ పర్సన్ వెళ్ళి చెక్ చేయడం అనేది కొంచెం కష్టంగా ఉంటుంది సార్. అంటే
ఇది
50
కష్టమా
రూమ్స్ని
లేకపోతే అందరూ అది కాదు, ఇది కష్టమా లేకపోతే 50,000 మందిని కూడా గ్రౌండ్ లోకి పిలిచి అక్కడ చెక్ చేయడం కష్టమా?
అది ఇంకా డిఫికల్ట్ సార్.
మరి అది యూ షుడ్ టెల్ ది వాట్ ఈస్ బెటర్ ఆర్ వాట్ ఈస్ బెస్ట్ అమాంగ్ దీస్ టూ. ఈస్ బెస్ట్.
ఎస్ సార్, దిస్ ఇస్ బెస్ట్ వే.
విచ్ ఇస్ బెస్ట్?
ఎస్
టెల్ మీ విచ్ ఈస్ బెస్ట్.
సార్, అదే 50 రూమ్స్ డివైడ్ చేసాం కదా సార్, అదే బెస్ట్ సార్.
Yeah, so HR person should go to each room and just get the count of who are working for HR department, right?
Yes, sir. Yes, sir.
Yeah. Okay. So this first case is HR person will go to each room and get the count and then he add it. Okay, how many people are there in room number 1, room number 2, room number 3, room number 4, like that. He will get the count. Okay, then he'll add all the 50 rooms HR counts and he'll give, okay, these are the total HRs. And second option I said is move all the, vacate all the rooms and pull them into a ground and vacate all the departments from all the rooms and put them in the same ground, and then you check their overall. Okay, that is definitely a big task because moving 50,000 employees into one place is a very laborious. Think about people moving through lifts or staircase and going to assembly area. Definitely it involves a lot of efforts and energy and time and all. It will take time or no?
Yes, sir.
Yeah. So next case is, so among these two, one person going to each room and getting the count is easy. Yes or no?
Yes, sir.
Yes.
Okay. So the next case is keep all the departments are how many? Departments are how many? 50.
Sir.
Yeah. Employees are how many? 50,000. Okay. But in a room, how many are there? Because there 50,000 people are not in one place. Okay, they are divided in each room. So in each room you have 1,000, 1,000, 1,000, 1,000. So, but departments all together there is only 50. So what if you put all the 50 people? Here we cannot put the same person in one room. But let's say I'm saying, what if you put all the 50 people in each room? Because in the data we can do that. Okay, in case of persons we can't do that. but let's say you put all the 50 people in the same room. Like that, every room you put 50, 50, 50. Let's say they are there like that. In every room there is 50, 50, 50. Then who are working for HR department? Okay. In every room they will get the local count, right? Hello.
Yeah, that they will get, sir. But can you once describe the scenario that you mentioned now? Like 50 people, how it come?
I'm saying 50 people, let's say all the departments, okay, 50, you put in every room.
Okay.
Okay, the 50 departments you put in every room. Okay, in persons we cannot put, but data we can put it, right? Something like 50 departments, you just you put some 50 department numbers in the every room.
Yeah.
Okay. Yeah, then if you ask in every room how many people are working in HR department, you will get count locally, right? In every room they will say, okay, I'm HR, I'm HR. Like that, every room you will get total number of HRs, right?
Yeah.
Yes, sir.
So what I said here, what you thought is you put these 50 people in every room. Because why I'm saying 50 people in every room means today's query is only department number HR. So next query is going to come who are working from sales department. The next query may come from who is coming working for production department. So in order to address any sort of query, so I'm putting all these 50 people in every room so that all these things can be answered in every room anytime for any sort of query. Okay, so for now I have taken one example, like who are all working for HR department, and immediately in every room what they will say, yeah, I am like that. So every room they will get the count immediately. Till this point you understood?
Yes, sir.
Prasad,
Yes, sir.
you understood till this point?
Yes, sir. Yes, sir.
What about Somnath? Somnath, you understood?
Oh, sorry, sir. I was speaking on mute. Sorry. Sir, what I was saying is I got little confused. So we have 50 people in each room and we have 50 rooms. That is what you are saying?
Yeah, tell me. Right.
So 50 people in each room and we have 50 rooms, but how many departments we have here now?
Can you hear me clearly, or is there any voice lag or break?
Yeah, I can hear you now, sir. Yeah. Initially,
Okay.
we discussed about 50,000 employee, 50 departments, and 50 rooms. So we then looked into first method and second method. And in the third method, you were mentioning about putting the 50 people in each room. So I just got confused. So there are 50 rooms, so 50 and 50 people in each room. So then the employee count is 50,000 or it got reduced?
Employee count, employees are same. They are there in every room, 1,000 people. We are not touching employees. We are
Okay.
only these 50 people are there, right? We are only keeping 50 people in every room.
50 HR
Okay.
people.
Not 50 HR people. 50
Department wise, sir.
department. Yeah.
Yes.
All departments are only 50, right? So those 50 people, okay, so we are putting in every room. Think generally we cannot put 50 people same time, but let's say we are putting, or these 50 people moving, I mean moving means it will be like one after another, but let's say these 50 people are present in every room.
In HR department, every room has a 50 members in HR, right, sir?
Boss, how many departments you have?
50
50,
departments, sir.
right? Yeah. So that means
In
50
in
people.
each room,
Yeah. Each person representing
each
one
room,
department.
yes,
So these 50 people you are putting in each room, I'm saying. These 50 departments you're putting in each room. Hello.
Okay, 50
You, for
departments we are
example,
putting in each room.
hello. For example, you see, wait, yeah. You two are two departments, okay? You two are two departments, okay? Okay.
yes,
You
sir.
two are two departments. I'm putting you two in 50 rooms, same time.
Okay.
Yes, sir.
You got it? I'm putting
Yes, sir.
you two are representing two departments, okay? I'm putting both of you in 50 rooms at the same time. You're clear?
Yes, sir.
Yeah.
Yeah. So at that time, for example, Somnath is HR. So in every department, he can get the HR count, right? Because he is there in every room.
Yeah.
Yes, sir.
Sure.
You got clarity till here?
Yes,
Yeah.
sir.
I got it. So we have 50 department people in each room, so that if there is any department that needs a count, that guy can, from that department can count it locally in that room.
Yeah, that's right. Yes. Okay.
Yes, sir.
Yeah. So yeah, that is the reason. For example, you see, we have this all distribution style. Okay, they are putting it in every node. Of course, they'll put it in one slice. Okay, first slice. Because if you put a person in a room, you should allocate him one bed, right? You should give him a bed or no?
Yes, sir.
Yes.
Yeah, for example, you have 50 people you're putting. Actually, yeah, there are 50 people in the room means what? They are actually sleeping on 50 beds. Similarly, you are putting one person in a room means, yeah, he will be there in one bed. So the all distribution style, what it will do is, it will put in first slice of each node. Okay. And the other table is already 1000 employees are already there. Okay, they are there, and these 50 departments are also there in that room. You understand?
Yes, sir.
Yes.
Similarly, in second room also, those 50 employees, that 1000 employees are also there, and these 50 people are also there.
50
Similarly, in the
departments.
next room also, 1000 employees are also there, and these 50 people are also there.
Yes, sir.
Yes.
Okay. So why they did it like that? Because for any query, it can be answered immediately. You understand?
Yes,
And
sir.
this is for distribution all you are saying, sir?
Yes, sir.
Yeah, distribution. I
Yes.
mean, how it things will happen in case of one of the table is distribution all.
Okay. Yeah.
Yeah, this third case is
Department table.
for, yeah, department table is distribution all, because it is small table, right?
Yes, sir.
In distribution all only, the whole table is put in one node, right? I mean, in first slice of each node.
Yeah. Sir, first method, what it was? What distribution?
I will tell you. You understood this?
Yeah, I understood. Yeah. Yeah.
Yes, sir.
This third case you understood?
Yes.
Yes. Yes.
Yeah. So yeah. So actually our scenario is employee table distributed on employee ID, department table distributed on department number. Okay. So that means both are distributed on their own case. So at that time, At that time, you see all the employees working for a particular department will not, they may not have their department number in that room. Yes or no? Because out of 1,000 employees, they may not, some employees may not be there in HR, or HR may be there in some other department. So just because he is in other department, they cannot say that I am not from HR department. Yes or no?
Yes, sir.
Somna?
Yes, sir.
Yeah. So okay. Now I'll tell you. Okay, so in that case only this will happen. So at that time, the best method is keep all the departments in each room so that any sort of query can be answered locally in the each room they will get. Understood?
Yes.
sir.
Yeah. Okay. But the even better than this is because here why we are putting all the people in every department at the same time. Of course, we cannot put persons, but yeah, records we can put it, right? That's why I gave this example, right? At the same time, one person cannot be present in two rooms, right?
Yes.
Yeah. But here since it's data, so we are placing the table in each node, and we are doing okay, cool. So, but let's say take this key example, okay? Employee table as department, okay? Department table has also employee table has department number column or no? Can you tell me employee table has department column or no?
Yes, sir.
Okay, department table has department number column or no?
Yes, sir.
Okay, cool. Now I will say that all the employees should go to rooms based on the department wise. Means how many employees are there?
50,000.
Yeah. So I told them that all the employees should go to rooms based on their department wise. That means all the sales people will go to one room. Okay. All the
Yes, sir.
HR people will go to one room, and all the marketing people. So the totally all the 50,000 people will go to how many rooms?
50 rooms.
Yeah. Somnath, how many rooms?
50 rooms.
Yeah. Yeah. So yeah, all the 50 rooms, right? So, but in each room, what type of employees you have?
Department wise, sir.
But
Yeah, that means in every room, all the employees are from same department. In
Same
for example,
department.
room 1 they are HR, room 2 they are production, room 3 they are sales, room 4 some marketing, room 5 some transportation, something. But in each room, people are from same department. Yes or no?
Yes, sir.
Yeah. Similarly, now the department table also distributed based on department. So department table also, the person from sales will go to sales room only, right?
Yes.
Hello. Because
Yes, sir.
departments also we have 50. So the
Yes, sir.
person department sales department person will go to sales room, marketing department person will go to marketing room, HR department person will HR room. Yes or no? Similarly, 50 people are there, so 50 departments they'll go to their respective department room. Yes or no?
Yes, sir.
Okay, no. Employees are also from same department, and a department also from same department in every room. Yes or no?
Yes, sir.
yeah.
I want yes 2 times. Yes or no?
Yes,
Loudly.
sir.
Yes.
Yes.
Yeah. Okay. So in this case, if I want all HR, They're already there in same room. Yeah, we are all HR because in fact all the rooms itself are divided as HR because they are distributed based on department wise, both the tables. So okay, HR, okay, immediately they'll go to some room number 1. Yeah, these are all HR. I want sales. Okay, they are in room number 5. These are all sales. They are say marketing. Okay, they are in room number 10. They are not. So this is easier or no?
Easier, sir.
Huh?
Yes,
Yeah.
sir. Yes, sir.
Yes.
Easier.
So this is what will happen if two tables are defined on same distribution key. Because people are available in the same room. So locally, yeah, we're all same. Okay, locally join will happen.
Okay.
If both the tables are based on same distribution key.
Yes.
Because see, I will tell. See here, department, for example, you see here, department number 10, it comes from employee table or department table. It will go to same slice or no?
Yes, sir.
Yeah. Similarly, department number 20. Okay. T1 means this 20 value coming from table 1. T2 means this 20 value coming from T2. So if the value is same, it comes from T1 or T2, they will go to same slice.
Yes, sir.
Similarly, 30 value, if it's coming from table 1 or 30 is coming from T2, they will go to same slice. The same thing like if a table or two tables are distributed on same distribution key, same values here means matching values will go to same slice.
Yeah, but if the number of records does not match in both, like it is not completely divisible.
Sorry?
So in like here, like suppose 49,050 department, then it is not properly divisible, right?
Properly distributed, is it?
Yeah. So if there is 49,000 employees and there are 50 departments, then there will be not be even distribution. Like so, if it is
Yeah,
50,000 and 50,
yeah, obviously that means you see, obviously that is right. You see, HR department will not have 1,000 people, right? HR department will have hardly some 50 or 60 or 100. And production people will have more employees. They may have even 25,000 employees, even from production people.
yeah.
Yes
So
or
in
no?
that case, there will be say suppose 9 records from table T2, or there will be 9 records of one HR and 1 record of another department, making it 10.
Yes, wait. I'll answer your, I mean, the before question. So when you're especially when big table, small table, okay, if they are based on same key, yes, uneven distribution will happen. Okay, that is the point. I mean, what you said, and I'm just confirming. Okay, for example, yeah, 49,000 employees, but you have let's say 50, but it's not. And also I should confirm that it's not that each department will have same number of employees. That you should note the point. Yes or
Yes,
no?
sir.
All
Yes,
the
sir.
department, you see, in any company, only HRs will have hardly some 100 or 50, or not even 50, yeah, something like let's say 100. And transportation, of course, another maybe 50 or 20. Who are the most of the employees? Tell me, either production people or something. Generally, the production in a company, for example, we are working in IT company. Who are the most people? Is it HR or is it transportation or is it the reception? Who is? The software engineers are the more people, right?
More.
Out of
Yes,
even
sir.
a company has some 3 lakh, out of 3 lakh, 2 lakh 80,000 only software engineers, only some
Yes.
20,000 all together, HRs, transportation, reception, security, everyone together. Yes or no?
Yes, sir.
Yeah.
Yeah. So definitely when two tables are distributed, so yes, if the more people are there in one slice, that's fine. But locally join is happening, right? You're not moving that anywhere.
Yeah.
You got
Yes.
my point?
Yes, sir.
Somnath,
Yes.
you got it right?
Yes,
Yeah.
sir.
Got it.
Yeah, because they're all there in one place. So that's all their queries are answered there itself. You're not moving anywhere. Okay, cool. So then you say that, yeah, it is leading to skew. Okay. So yeah, this is the case in case of big table, small table. Yeah. So the big table department having more employees will be there in one slice. So, but one slice also, because they are distributed in same joining column, so we are not seeing any issue. Actually, two tables distributing based on joining column is good, whether it's a both are big tables or one is bigger, one is small. That is always the number one option. Okay, because they're distributed and every query is answered locally. All the join is happening locally. In the same room, everything is being done. You don't need to go outside of the room. That is best or no?
Yes, sir. Best. All is best.
Yeah. Sorry, what you said, Prasad?
A key all is best, sir.
No, key is always better, not all. Key is
Yes,
always better. Both the tables are distributed based on the key column. I mean, same
yes,
key
sir.
column, same key column. Okay,
Yes, sir.
on their joining column, that is always better.
Yes, sir.
Somnath, can you follow me?
Yes, sir. Yeah.
Yeah, but yeah, but in case of one is small table, one is big table, it may give some skew because yeah, the big table will have more record count and small table will have less record count. So we may feel like some skew. It has some skew, but even okay. So we may feel like that. So then, but since data is there in same room, or I can say room or slice, so that is always better. Or if you think that no, I don't want like that, okay, I don't want based on the department, I mean same column, I will give okay some employee ID, but employee ID is never used in the join. Okay, so but no, I want to distribute evenly. Okay, then distribute based on employee ID, then all the departments will employees will be distributed evenly, but at that time you may not have the matching department number in every room. Yes or no?
Yes.
Yes, sir.
Yeah, that's where you may go for department number all. At that time department number you should put all instead of department number as the distribution key. Because if you put all, what happen, entire copy will be present in every slice, so locally it will join, because this table copy, complete copy is there, right? So in every room they will see okay who is from matching value, because all the values of another table is present there. You got all importance in case if you are not distributing based on key.
Yes, sir.
Yes, sir.
Prasad, yes,
Yes.
loudly, or I mean,
Yes.
if you are
Yes.
not
Yes.
clear, ask me itself.
Yes. Yes. Yes, sir. Clear, sir.
Yeah. So yeah, that's what. So if both the tables are distributed based on key, that is always best, and that key column should be joining column, means they will have matching values. Yes or no? Because
Yes,
if
sir.
both same column is the key in both the tables, oh no problem, because matching values will be there in the same okay place. Okay, so the locally join will happen. No further movement is required. See, for example, you are there in UP, Somnath is in UP, okay, and Prasad is in some okay Vijayawada, I mean okay AP, I mean okay. But for example, I am also in UP, let's say. Then two people in same place, that is always the better, right?
Yes.
Hello.
Yes. Yes. Yes, sir.
Yeah. Same thing. If you have two tables based on the same distribution key means the key should be same in both. That's always better because they are in the same place. They can talk, they can walk. If you go to office, what happen? If you go to office, you can do anything. You can talk, you can walk, you can go to canteen, you can ask doubts. If you don't know something, you can come, you can ask me, because we sit together. So, but what happened? For example, you are in UP and I am in AP. If you want to meet, forget about this online trainings and all. Either I have to come to you, or you have to come to me, or we should go to some place which is closer. I mean, which is just exactly near to both of us, and we should meet there if you want to meet. Yes, sir. No.
Yes, sir.
Yes.
Yeah. So if the both the tables are not defined on key same column, I mean, definitely in production that is always possible. It's not that all the tables are always same column. Okay. So at that time, that is the reason small tables will be defined as a distribution style. All then the same copy will be present in everywhere. So that will be the next better way. For example, let's say I am present in UP and I am present in Vijayawada. I mean, at the same time, let's say, then that is the next better way, right? Both of you
Yes,
can
sir.
interact with me same time and you can get whatever you want to get.
Yes.
Yes or no, Somnath?
Yes, sir.
Yes, sir.
Yeah. So that is the all is the next best method. Okay. So even we don't know which record will go to which slice, because this is just evenly distributed. For joining what? Joining, you see, that's the last time we have discussed about some joins. I mean, on a high level, matching value should be there, right, for joining. Okay, if it is distributed based on some column, okay, some unique column which is not used in join, it may be there present in some slice. Okay, but the other table joining column may be present in some other slice. Then how do you join? You understand? Because for joining what? Both the values should be present in same place, right?
Yes.
Hello?
Yes. Yes.
Yeah. But they are not present in the same place. Okay. So
Yeah.
they are not present in the same place. See here. Table 1 is the even distribution. So it is just randomly distributes X, Y, Z, or A, B, C, D, E, F, something like it will just distributes. Okay, 1, 2, 3, 4, 5, 6, 7, 8, or A, B, C, D, E, F, G, H, I. So it will just randomly distributes. All, yeah, of course, all is present in every slice. But yeah, in other table is all, then that's fine. Okay, because every copy is there. So the whatever X come, it will just join with this. Whatever Y come, it will join with the copy available here. You understand how all is helping, even in case of other table is even.
Yes, sir.
Yeah.
Hello, do you
Yes,
understand?
sir.
Even if the other table is even, all is helping or no?
Yes, sir. Helping.
Somnath?
Yes, sir. Yeah.
Yeah. So even the other table is all. I mean, other table is even, all is helping us because the entire copy is present. So whatever record is there in that slice, it will join there. So no problem. Of course, if both the tables are all and all, there no problem, because that table copy also available in the slice one, and this table copy also available in slice one.
Yes, sir.
Somnath, you
Yeah.
got this point? If both are all and all.
Yes, sir. Yeah.
Yeah. So yesterday, I think Somnath asked one question. So both the tables, I mean, in case of all only that question you asked, if both, for example, both the table copies are available in slice one of each node. So in node in slice 1 also, in node 1 also the copies are there, node 2 also copies are there. Like that, if you have 10 nodes, in every node in first slice both the copies are there. So do you think that join will happen in all the 10 nodes in case of all and all? Somnath, because both the
Yeah.
tables are present in one node only, right? So
Yeah.
so it will do join at one place. That's all. No need to join in every node. Got it?
Got it.
Prasad, you understand what I was talking?
Yes, yes, sir. Yes, sir.
Yeah, because you see, for example, I'll tell you another. Okay, T1 is all distribution style, right? So T1 is present in the slice 1 of node 1. Similarly, T1 is present in the slice 2 of node 2. Like that, even if you have 100 nodes also, it is present in the first slice of each node. If you give select star from T1, select star from T1, do you think that it will go to all the 100 nodes and get from the first slice T1 data? Answer me, Somnath.
No, 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 sir. Only first
Yeah,
node.
yeah. Who is that? Prasad?
Only first node will get the data, sir.
Why?
The same copy will be available in each node of first slice, sir.
Okay.
Only the getting information only for taking first node of first slice.
Is enough, right? Is enough, right?
Yes,
Remaining all only it's
yes.
a duplicate data.
Duplicate data.
Yeah, so you don't have to issue the same select star from table. In fact, this all will be taken care by the later node. Don't worry. But I'm telling because yesterday same question is asked by Somnath. Does the operation happen in every? In case of all, no need to fetch from every copyright because
Yes,
entire data set is there in first slice itself. So it will perform that operation in one node. Okay, I mean the copy that available in that node. That's all. You don't have to do that operation in every node because anyway it's a repetitive operation. No use, not required. Yes or no, Somnath?
yes,
Yes, sir.
Yeah. So actually the whole funda of these cases is depending on only one thing. What is that one thing? To join, to join, matching values should be present in the same place. Yes or no? You see, if
Yeah.
you
Yeah.
yes,
want to meet, we should
yes,
be
sir.
present in the same place, right?
Yes,
If you want to meet, we should be present in same place, right?
yes,
Yeah. So for that only, what we say is try to keep the same distribution keys for the joining tables. Okay. If because at that time matching values will be same present in the same slice. Okay. If you say that no, I cannot do like that, then small table you keep distribution style all, and other table you can put whatever you want. Means generally the most unique column you will define. So that since the copy of this data is present in all the nodes in the first slice, so this also will facilitate local matching. Okay. So yeah. So but
Yeah.
if that is not the, but yeah, all and all also fine because it will just perform in the one of the slice because both the copies are there, that is available. But some two big tables, okay, some two big tables are some distributed based on join or something. Okay, I mean distributed based on, okay, so not distribution key and it is not all. At that time what happens? Okay, so at that time we see two big tables. Okay, they are, let's say, even, both are even. or they are not, and both are even, or one is even and another one is key, or both are keys but not on the same column, not on the same joining column. Okay, for example, you see customer table distributed based on customer ID and orders table is distributed based on order ID. See, both are very large tables. Order table, it will have billions of records. Okay, it is distributed based on order ID, and customer table distributed based on customer ID, but both are joined based on order number. But customer, yeah, order table is already distributed based on order ID, so no problem. But customer table is not distributed based on order number, it is distributed based on customer ID. So what happened to join them? Customer table has again need to be redistributed based on order number to join them. So here two things can happen. See, T1 means table 1, the customer table, it can be redistributed based on the joining column. Or if table, I mean that customer table is also too big, what happened? So they both can bring to disk. Because why we are moving data like this? Why you understand customer table and order table? Order is already distributed based on order number, but customer is not distributed based on order number. So you have to redistribute customer table again based on order number. Why order number? Because order number values, if you want to match it, order number from customer table and order number from order table should be present in the same place. So customer table will be redistributed again based on the joining column. Okay, that's why, I mean, these are the problems if you have different distribution keys for different tables other than joining column. That's why always try to keep joining column as the distribution style. Okay, and small tables as the all distribution style. But yeah, for example, in the case like customers and orders, it's not possible. So at that time, yeah, Redshift or any database, okay, BigQuery or anything, it has to redistribute the other column which is not distributed based on joining column with the joining column again during query processing. At that time only queries will run faster. So if you want to improve the performance, create customer table also with order number as the distribution key. This is very important point. Did you understand? If you improve the performance of such queries, what you have to do? Already order number is distributed based on order number. Okay, order table. But customer table is not distributed based on customer table, customer ID. So, but it's joined based on order number. So you have to change the distribution number of customer table to order number, so that again it will be stored in every slice based on order number. So locally join will happen. That means you are suggesting to change the distribution key of customer table to order number rather than customer ID to improve the performance. Are you clear?
Yes, sir.
Somnath?
Yes, sir. Sir, I got what you are saying, but I have to revise on like on I have to go through the recordings once.
Yeah, you can go to recording, but yeah, you see, I'm telling, very, I mean, a lot of working experience. Unless you also work, you cannot realize what is going on in the database or how the database is actually doing things. But for now, this is theoretical knowledge. But if you present this theoretical knowledge, you will be selected.
Okay.
Okay. Yeah. So if you understand like how, okay, I mean, even you talk the same words that I talk, that means he will think, I think he must have seen some of the explain plans while doing running queries or something like that. We will think. If you're talking, that means unless you saw it from your own, you cannot talk it like this. Okay. So in that way, interviewer will think, I think he must have, I think, yeah, saw. Let's say he was talking like this. He will feel. Okay. So here, very simple. To join two tables, value should be present in the same slice. So for that only you have to keep the joining column same distribution key as their, or you can keep their joining column as the distribution key. That is the most faster. If that's not possible, yeah, one of the table will be redistributed. Yeah, that you cannot avoid it. Okay, one of the table will be redistributed. Okay, so yeah, why it's redistributed? It is redistributed to match the joining values. Okay, so if one of the table is small table, then you can always keep it as a all distribution style. So since that copy will be present in every slice, that will help, okay, to join locally. Okay, so all will always help. Even the other table is a, I mean, if it is distributed based on any column, because this table is already present in every slice of each node. So yeah, it is next better. Okay, so yeah, if both the tables are in even, that is the worst performance. If both the tables are distributed based on even, that is the worst performance. So that's in that case only. How do you address? Yes, you have to change the distribution keys to the joining column. But the problem is they are not distributed based on their joining column. Rather, they distributed based on even, means randomly, round robin. So you have, since you are joining those two tables, means you're already joining on some column. So you better have that joining column as their distribution key. That will help improve the performance. These are all related to performance. Okay, very advanced. So
Yes, sir, I
since
will
we
go
are
through
playing,
them.
sorry.
Yes, so I will go through them, sir. Yesterday, sir, you asked one question, right? If a table has data 100% unique
Just second,
and
just second, just second.
okay, yes. Am I not audible, sir? I lost. Yes, sir.
No, I put on mute. Okay, yeah. Yesterday, yeah, that question answer. Tell me now, what is the question and what is the answer?
Yes, the question was you asked me whether if there is a table which has 100 and a column, two columns, one column with 100% unique data and another column with 80% unique data. So which column you will use as a distribution key? And that was the question, right, sir?
Yeah, right.
Yeah, sir. The answer should be that and the column with the 80% distribution unique data, and because that is the column that is used in join conditions. Is it
Yeah,
the
why?
correct
Now you tell me. The answer should be, yesterday also you told answer till this, but now why?
Yeah, that is also thinking, sir. Max, any help tips you can give? I can think on that direction.
No, you see, in today's class, I have already answered, right? If the joining column is the distribution key, data will be locally available. So it will improve the performance. It will avoid the data redistribution during the joins, because joining column is the distribution key. So there is no further data movements during processing, because data will be available locally in every
Okay,
slice.
please.
You understand?
Yeah, sir. Yeah. Okay.
Yeah, because today's whole class is on that only, right? How to avoid data redistributions during query processing. If you define distribution key on that column, it is already distributed based on the joining column. So no further movements are required. Data will be available in the same slice during query processing. So it will be definitely faster. If you define based on another unique column, what happens? Since that is not the joining column, redistribution need to happen during query processing. So it will take more time.
Okay. Yeah.
Understood? Somna?
Yes. Yeah, clear, sir. Yeah.
Prasad, you understood why joining column will improve the more performance, or why we should create a column which is used mostly in joins rather than the column which is more unique? Hello? Hello, Prasad, can you hear us?
Yes, sir. Yes, sir. Some distance.
You understood? You understood to that question
Yes, sir.
answer?
Yes, sir.
Yeah, can you answer why? My question is, a table has one column which is 100% unique but not used in the joins, but another column which is not 100% unique, only 80% unique but used in the joins. Which one you will prefer as the distribution key and why? Can you answer? Hello?
Yes, yes, sir.
Are you answering?
No, 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 sir. Actually,
Hey, want to tell Telugu in tell man. Tell in Telugu, no problem. But first of all, you understood or not? Huh?
um, yes, sir. 80%, 80% is unique, sir. 80% unique means అది ఎలా ఎక్స్ప్లెయిన్ చేయాలో నాకు అర్థం అవ్వట్లేదు సార్ అది.
Boss, the column which is 100% unique, okay, but it's not used in joins. What is the use of that column during joins? Because it's not used in joins. So rather you will create distribution key, the column which is 80% unique but used in the join. If it is used in the join, so what happened? It is distributed based on the joining column to all the slices. So other table is also distributed based on the joining column. So locally join will happen.
Yes, sir.
Huh? Hey, Somnath,
Yes, sir.
can you drop your phone number here? He will call you after when he is free. Both of you discuss this. I mean, not only this, every concept every day.
Yeah, yeah, sure.
Okay, you teach him whatever your understanding, so that
Yes, yes.
you will know whether he will know or not. That's a different matter, but you will know better.
Yes, yes. That is okay for him, sir. Yeah. But yeah, sir, you can
Yeah.
share the recording. I also have to go through once. Yeah.
Yeah, sure. Okay, just share your understanding with him, and if you both of you need clarity, you just ask me in the next session. In that way you will get more familiarity with the subject matter. Okay, Somnath?
Yeah, sure, sir. I definitely will have questions. I know. But yeah,
Yeah.
I will go through so that I don't do duplicate questions.
Prasad, you got his number?
Yes, sir. Yes, sir. I got it.
Yeah, save that number and call him. I mean, check with him when he is free. I mean, you can call
Yes, sir.
him and both of you interact and just see the end of the subject. In that way only, both of you do research, whatever time you can spend, you can easily get master of this. And if you need any clarification, just ask me in the next session.
Okay, sir.
Okay? And Somnath, yeah, I'm telling you with experience, the more you, I mean, try to explain to others, the more you will know rather than that guy. Whether he knows or not, that's a different matter. And sometimes he don't know also, he don't get also. But don't worry, you will get it better.
Correct. Yeah. Yes, sir.
Okay, Somnath?
Yes, correct.
Yeah. So if you think that you also need clarity, you just ask me in the next session. Okay?
Yeah, so sir, yeah. So what I'm thinking is I
Okay.
will go through this distribution in the weekends and I'll ask you my question on the distribution on Monday. That should be good for you.
Yeah, sure.
Yeah, and
Okay,
go
sure.
through yesterday's, today's, and tomorrow's class on Saturday, Sundays, and we'll discuss it internally, and then we'll have our questions to you on Monday on this.
Actually, you saw my demo on YouTube video, right?
Yes.
I'll upload all the videos to YouTube itself. Okay?
Okay.
Yeah. So I think all the videos I'll upload. I think video we need to download. But say something I'll figure it out. But I'll upload them also. You can see there itself. Not for now. At least I'll share the links. Okay?
Yeah, you can share the link.
Okay, cool. Thank you all. Then see you tomorrow.
Thank you, sir.
Yeah. I mean, Prasad, because Somnath is a working employee, so he is capable to answer anything. Okay, if you need anything
Yes, sir.
further, definitely both of you can come to me.
Yes, sir.
Okay. Okay. Cool. Sure. Take care. Bye.